A star 600,000 to 3,981,000 times more brilliant than our Sun, displayed around 13 billion light-years away, has now been centered on by the Webb telescope. It is the most advanced telescope ever and has opened new insights from the star of astronomical daybreak. It could be possible for researchers to make sense of, for the first time, how the first stars in the universe truly came into being. It was a shocking revelation when the old Hubble Space Telescope first found a star so far away that it blew researchers' minds. It's no big surprise that a star existed in space a long time ago. The marvel is somewhat that we can see it from Earth with our telescopes. The light from this star traveled 13 billion light-years through existence before it hit Hubble's somewhat maturing perception. The discovery of Ural, the most ancient single star in the universe, was a late brilliant idea for the telescope. Another scientific marvel is the fact that the star should be visible away from its galaxy. This is possible because Endel was superimposed by a gravitational lens. Gravitational lenses are formed by solid amplifications when a huge mass lies before a distant object, extending spacetime in such a manner that it behaves like an amplifying glass. Endel was subsequently optically broadened out of its world. Revealing stars at these distances is, however, nearly impossible. What do such finds reveal to researchers? It's very simple. If we see a star that is representative of the youthful universe, for the first time, we finally understand what the stars of the first age truly looked like. If we have insights into these stars, we can follow the history of the development of the universe and find answers that are critically needed. As of not long ago, we had no certainty about what the first stars looked like. We had speculations but no proof. Endel should be such evidence. However, then the new Webb telescope came along and turned everything upside down. Endel, what Webb really saw. Could you imagine how a single star literally turns into a whiz after its discovery? Endel raged the media, and the reports came thick and fast. With the discovery of this oldest known star in the universe, the question of how the universe truly appeared should finally be answered. Researchers were sure that, quite a while back, the vast dawn broke, and the once dim universe was slowly illuminated by stars. Endel is an early English term meaning morning star or rising light. Some of you may also be aware of the name from the book Asterisk, The Silmarillion Asterisk by J.R.R. Tolkien. So, Endel was given a truly legendary name, and for a while, it looked as though this star would truly go down in the history books. But then came the disappointment. Endel is old, extremely old. However, it is in no way the most ancient. In fact, Endel showed no irregularities that distinguished it from today's stars. Really, stars from the first epoch of the universe should be blue supergiants, up to multiple times bigger than our Sun. These stars are said to have had only a short life expectancy. Endel did not disappoint specialists when it came to radiance, being between 600,000 and 3,981,000 times more brilliant than our Sun. The star was really bright and enormous. Anyway, further investigation showed that it was the same in composition as today's giant stars. Endel, subsequently, showed no proof of being a primordial star. Soon after its discovery, science was dealt the next blow. The new James Webb Space Telescope found even more ancient stars and galaxies that are far older than Endel. The so-called Star of the Dawn was therefore downgraded from a whiz to merely one of many that existed at a maybe unremarkable time in the universe. Endel's light was emitted about 13 billion years ago. The galaxies found by Webb were already emitting their light in space 13.6 billion years ago. This means that many of the stars in these galaxies were, and are, around 600 million years older than Endel. By the way, the star remained the focus of science, even if Endel had to quickly surrender its top position among the oldest stars in the universe. It's still an exciting discovery. The radiance of a single star from this epoch reveals significant details to researchers about the composition and, therefore, the evolution of the star. Telescopes like Hubble and Webb can break down the light waves into individual frequencies. The analyses then permit detailed predictions to be made about which gases the star was fusing, how old it was, which astronomical class it belonged to, and whether it was surprising in any way. These investigations led to another little sensation. The James Webb Telescope found evidence of a cooler, redder companion star in the star's environment. This could imply that we are dealing with a double star system consisting of an extremely large and hot star and a smaller one. This possible binary star system raises new questions about the evolutionary history of the first stars. Binary stars in the early universe have seldom been considered. The cool companion star could help determine the chemical structure and age of the system more accurately. It is exciting that such systems could also provide insights into the interactions between massive stars and their surroundings. Such pairings might influence the distribution of heavier elements in the early universe more than previously thought. Further observations with the Webb telescope should now clarify whether this is indeed a binary system and what role it played in the development of the first generation of stars. These are the oldest stars in the universe. Can we really be certain that we are seeing the oldest stars in the universe? Since the discovery of Endel and the subsequent scientific bust, scientists all over the world have become more wary while choosing names like Dawn Star or similar titles. Meanwhile, gravitational lenses have provided further sightings of individual stars in the universe, making Endel appear to be a spring chicken. SMSS J0335 4007 is nearly as old as the universe itself, at over 13.6 billion years old. It was found in the corona of our own galaxy. This star is, therefore, likely one of the oldest in the system. This star actually contains very few heavy elements, so it may be a direct relative of the first stars. The low metal content is considered typical for stars that were formed in an early stage of the universe and exploded as supernovae only a short time later. Examination scientists were thrilled by this discovery, as they finally saw their speculations about the first light giant stars confirmed. Then, HD 140283 appeared and turned everything upside down again. Estimates showed that this star is around 14.5 billion years old, found around 190 light-years from Earth in our own galaxy. This star would be older than the universe itself. HD 140283 went down through the entire history of cosmology as the Methuselah star. Specialists still can't explain the existence of this star to this day. The sheer incomprehensibility of the star even drives some researchers to claim that it may just be an estimation error. He 1523 to 0911 was also found in our Milky Way and is around 13.2 billion years old. Certainly. Here's the text with punctuation added for clarity. Estimation mistakes can be precluded here. This star was dated utilizing a very precise technique based on uranium and thorium estimations. H1523091 is, accordingly, perhaps one of the oldest stars whose age has been definitively decided. It surely existed 600 million years after the Big Bang, which would pretty much be viable with the old speculations. However, then came BD plus 17°3248, which at around 13.8 billion years once again calls the Big Bang into question. This star also contains uranium, whose decay is an ideal instrument for determining age. The surprising age of this star could, in this case, be determined more than likely. If it truly existed 13.8 billion years ago, it cannot have formed simultaneously as the Big Bang. TAS J1180822025104378b is another candidate that challenges existing information. Its light was seen in the cosmic radiance of our Milky Way, and it was displayed there around 13.5 billion years ago. The very low-mass star shows signs of an original generation of stars. It was a huge light and presumably lived only for a short time. This could make it a direct relative of the first generation of stars. Anyway, this isn't yet proven. Scientists are earnestly looking for more and more proof of very old stars of population 2. These are believed to have been the very first stars in the young universe, around 13.5 billion years ago. Although the Webb telescope can easily see back to this time, so far, no proof of these star populations has emerged. The globular cluster M92 was dated to be around 13.8 billion years old. This could mean that the cluster was a kind of protosystem. However, with an age that precisely matches that of the universe, the globular cluster explodes the old timeline of cosmic evolution. These discoveries of individual stars, along with Webb's find of extremely old galaxies whose development extends beyond the Big Bang, show that the universe must be older than we previously believed. The universe is 26.7 billion years old. Do you also can't help thinking about why researchers are so certain that the Big Bang happened 13.8 billion years ago when no one has ever actually seen it? The dating of the beginning is essentially based on estimations of the astronomical background radiation, which was long interpreted as an immediate flash of the Big Bang. Other values, such as the expansion rate of the universe and the supposed Hubble constant, seem to support this hypothesis for quite a while. However, later discoveries and data raise the question of whether the universe could indeed be older than previously thought. Researchers found mistakes in the estimations of the speed at which galaxies are getting away from one another. Quite a while ago, the difference known as the Hubble strain might have been an early sign that the age of the universe was being misjudged. You can imagine how researchers approach this by treating the expansion like an inflated balloon. Assuming you let the air out of the balloon, all the visible matter would come together again at the starting point. This should be the Big Bang, 13.8 billion years ago. Further estimations and techniques confirm that the universe is roughly 13.8 billion years old. But now, there is a whole series of real evidence of stars and galaxies that existed when the universe was evidently starting. This real evidence throws all old hypotheses over the edge. The stars and galaxies are there. For sure, specialists can no longer claim that there was nothing at all back then or that the universe was just a hot, soupy mess with no real matter. Despite this evidence, a re-examining in science is, at best, advancing slowly. Imagine that you've had faith in something your whole life and defended that belief. Then, an event or a person comes along, and suddenly, something else must be true. The mind and, perhaps, a touch of willfulness and pride can prevent new, real evidence from changing old thinking. This is what's going on in our astrophysics right now. While many modern scientists welcome the developments, moderate researchers are stunned. They don't want to admit that the universe should be older and that old hypotheses are at least flawed. We are at a fresh start. A Canadian scientist presented a new age determination of the universe. He showed, mathematically and in accordance with the old physics, that the universe could also be 26.7 billion years old. Subscribe to the channel now and expect some new, exciting videos.